Hey guys, this is Claire, and today we're going to be going over the 6th question from the 2015 Calc AB test. So here's the question on my screen here. It says, consider the curve given by the equation y to the third minus xy equals 2. And it can be shown that dy dx equals y over 3y squared minus x. So part A asks, write an equation for the tangent line to the curve at the point -1, 1. So you might know that you can find the slope from the derivative equation, which is already given to us, because the equation of the derivative represents the instantaneous slope. So all we have to do to find the slope of this tangent line is plug in our points. And the equation that we're going to be using for the actual line is the point slope form equation, which is y equals s, which is some slope that we're going to get from the implicitly derived derivative. And then x minus, and let's say you have the point a comma b. So you're going to have x minus a, which is the x value of that point, plus b. So first we need to find the slope value, and that's pretty simple because we already have the equation of the derivative. So we're just going to use this equation, the dy dx equation. So we have that dy dx equals y over 3y squared minus x. And we have the point 1, 1, and we need to use -1, 1, and we need to use both of those points in this equation because we have y's and x's. So we're just gonna plug in -1, 1, and that's gonna give us 1 over 3 -1 squared minus 1. And that is gonna equal 1 over 3 plus 1, which equals 1/4. And this is going to be our slope. And now all we have to do is just plug that back into the equation. So we're going to get y equals 1/4, which is the slope that we got, x minus the x value, which is -1, so minus 1, plus 1 for the y value. And we can further simplify that to 1/4 x plus 1 plus 1. And there's no need to simplify this to the normal slope-intercept equation. It's fine to just leave this as the point slope form. So this is going to be our final answer for part A. Okay, so now for part B, it says, find the coordinates of all points on the curve at which the line tangent to the curve at that point is vertical. So having a vertical tangent line means that the slope at that point is undefined. So let me write that down. Vertical tangent line means slope is undefined. And having an undefined slope means that the denominator of that derivative function is 0. So that means that in our derivative function that is implicitly derived, y over 3y squared minus x, it means that this denominator is equal to 0. And that would make the slope at that point undefined, which means that the vertical tangent line would be 0. So all we need to do is set this denominator equal to 0. So moving the x over, we get 3y squared equals x. And obviously right now we have two variables, so we need to use another equation so that we can solve for both x and y. Unfortunately, we're given this original equation. That's not the derivative function. So that's just y cubed minus xy equals 2. And we know that x equals 3y squared from this first equation right here. So we can just do a simple substitution to solve for y. So rewriting this function, we get y cubed, and then we're going to substitute in 3y squared for the x, times y equals 2. So we get y cubed minus 3y cubed equals 2. And that's negative 2y cubed equals 2. Y cubed equals negative 1. So y is going to equal negative 1. And then we can substitute this value back in to one of the original equations to solve for the value of x. So I'll just use the first equation because it's simpler. So I'm going to do 3 and then negative 1 squared equals x. And I substituted negative 1 for y here. So I'm going to get 3 equals x. So the point at which the line tangent to the curve is going to be 3, negative 1, because that's when the slope is undefined. So on to part C. The question says, evaluate d squared y over dx squared at the point on the curve where x equals negative 1 and y equals 1. So basically what this question is asking us to do is find the second derivative of this original function, which is just the derivative of this derivative function that we were given in the beginning. So let's start by writing out the derivative function. The first thing that you would want to notice when you're trying to take the derivative of this is that you need to use the quotient rule, which is low times the derivative of the high minus high times the derivative of low all over the denominator squared. So what I like to do when solving quotient rule problems is first find the derivative of the numerator and the denominator separately. A common misconception is to say that the derivative of y in this case would just be 1, but that is not true because we're deriving this in terms of x. And so the derivative of y would be dy dx. And for the denominator, we can use the same concept of the dy dx thing, except now it's just a power rule. So you get 3 times the power of y, which is 2, and then y to the 1, because this power transfers over here, and then you subtract 1 from it. And then, as I said before, we need to multiply by dy dx because that's the derivative of y. And so we're kind of applying a chain rule sort of concept here. And then this is just minus 1, the x, because we are deriving it in terms of x, and dx over dx is just equal to 1. So now we can finally plug this into our quotient rule formula. And so we get d2y over dx2 equals low d high, so 3y squared minus x, and the derivative of the high, which is dy over dx, minus high, which is y, d low, which is 6y dy dx. Forgot the minus 1. All over low squared, which is just 3y squared minus x squared. So if they asked us to just find the function of the second derivative, this would be a lot more complicated because then we'd have to plug in to all the dy's this original function, and then simplifying that would be a really, really big algebra problem, and it would be really time consuming. But fortunately, it asks us to evaluate the second derivative at a certain point to get a certain value. So this makes our lives a lot easier because we already know the value of dy dx. We calculated that in part A. You know that dy dx at negative 1, 1 is equal to 1/4. So all we have to do is just plug this in to this function. So we have 3 times y is 1, so 1 squared, minus minus 1, because that's the x value. And then we multiply that all by dy dx, which is 1/4. And then we have that minus y is equal to 1, 6y, that's just 6, times dy dx, which is 1/4. Put another parentheses here, minus 1. And the denominator is going to be 3 times 1 squared, which is just 1, but I'll put it there for good measure, minus 1 squared. So 1 minus 1/2 over 16. It's going to be 1/2 over 16, which is going to equal 1 over 32. So that's going to be our final answer for part C. So you've now completed FRQ 6 of the AP Calc AB exam from 2015. Here's some extra videos and resources like textbook problems that you can use to get a better understanding of implicit differentiation and finding the tangent line. Although these are AB topics, they're also very applicable and important in Calc BC, so be sure you have a good foundation. Thanks for watching and hope that this video helped. Bye!